Hello, everyone. How are you? This is Francesca Lazzeri, and I'm here today because I'm going to talk about Azure Machine Learning. This session is about learning how you can use Azure Machine Learning to build your end-to-end machine learning and data science solutions. So I'm very excited to be here. As you can see from my screen, I have already opened Azure because Azure is going to be the platform that we are going to use for this. But before we get started, I would love also to share some slides with you because I think it's important to, again, try to understand, first of all, what is machine learning, or at least get an overview of what are all the possibilities that you have when you want to get started with machine learning, data science. And second, also, I think it's very important to understand what are the different tools on Azure that you have in order to do data science and machine learning. And we will see these together soon. So let me share my slides first of all. I would like also to share some resources with you. Let me make this bigger. Perfect. So as you can see from the title, we are going really to understand how you can do it all with Azure Machine Learning. I also put a short link there, is aka.ms/Azure Machine Learning. This is a link that you can use every time that you have a question or you want to learn more about Azure Machine Learning. This is our doc repo, where you can find many different documentations around Azure Machine Learning specifically. Today we are going to understand better also what are all the different resources that you can use in order to start learning about machine learning. As you can see here, I put also a video series on data science machine learning that I built with Sarah Gattles. As you can see, you can find it on channel 9, Dev Intro to Data Science. Then we also put together a GitHub repo. So this is a short link that you can use to find the GitHub repo with all the sample notebooks, slides, and explanations that we put together for this video series. Is aka.ms/devintro ds_GitHub. And then we have different concepts that we explain during this 28 video series. For example, the data science lifecycle, the algorithm cheat sheet that is about how you can pick the best algorithm for your solutions, automated machine learning, and today we will see also automated machine learning during this session, Azure Machine Learning Service, AutoML featureization, and how you can select machine learning algorithms, and finally also model interpretability. There are two videos around model interpretability in the video series. One is about ethics and data, and Sarah Gattles really does a great job at explaining why it is important to start with your data and how you can make sure that your data is representative enough of the population that we are trying to observe, to study, and how ethics is important and how is playing an important role in data science and machine learning. And the other video is more about the different toolkits that as a data scientist or developer you can use in order to make sure that ethics and model interpretability is integrated in your solution. So these are all the resources, and I'm going also to share them during this session, but let's get started. First of all, what is Azure Machine Learning and how you can use it on Azure in order to build your data science solution. First of all, it's important to understand that when you use Azure Machine Learning, it depends a lot on what you want to do and also what your preferences are, because because really there are many different options for data scientists and developers. Like for example, if you are a person who really likes to code and you want to build your machine learning model from scratch, for example, you can use the Python notebooks, as you can see from this slide. If you are a person that prefer also to use a drag and drop tool for your machine learning solutions because you prefer to see the end-to-end experimentation flow of your solution, and you like also to share the solution with other data scientists, developers, you can use Designer, which is again a drag and drop tool, and we will see that together today. There is also AutoML. AutoML is a great option for data scientists because it's a feature within Azure Machine Learning that does a model selection, the best model selection, and hyperparameter tuning for you. And finally, also RStudio is available for today for this session on the Microsoft Developer Twitch. We are going just to look at the first three options, so Python notebooks, the Designer, and AutoML. Another important thing to keep in mind is that always as a data scientist you build end-to-end solutions. So this is what it means. It means that you never focus only on the machine learning component, on the machine learning model. But as you can see from these slides, you always start with the data, and this data can be structured data, like for example forecasting types of machine learning scenarios, or also unstructured data, like a different type of machine learning scenarios such as NLP, vision, IoT. So there are many different types of data that you can use, you can leverage in order to build your end-to-end solution. And then another important aspect to understand is that you have always to store this data somewhere. You have to make sure that of course you can access them, and also that your data is refreshed over time, so that you can eventually think in terms of how I'm going to retrain my model, how I'm going to improve my model. And then when you get to the machine learning part, what we're going to see today is that again you have multiple options. Notebooks, these are Jupyter notebooks that you can use if you want to code in Python or R, automated machine learning, and Designer. These are the three different options in terms of authoring tools. And then there are different also MLOps capabilities, such as reproducibility of your models, automation of your pipelines, deployment of your machine learning solution. This is the operationalization part. And then the retraining part. This is the part that I was mentioning earlier, which is a very important part, especially for solutions that you think are going to be in production. How are you going to refresh the data and reuse that data for training, meaning making your model even more intelligent. Finally, another very important layer that you need to consider is the powerful compute. Here we have a CPU, GPU, FPGAs that are another option, or IoT edge. So all these options are there for you to build again end-to-end solutions. And then how are you going to consume the solutions? Most of the time you are going to deploy your solution, your machine learning models somewhere. Can be on AKs, or also in terms of batch prediction, you have other options such as a SQL database. And also if you want to get a sort of overview of all the analytics, and you can use the Azure Arc. So again, this is something to keep in mind every time that you start data science solutions, because again, you're not going only to focus on the machine learning model, even if that part is super interesting and super important, but you're going also to look at other different components. So in terms of tools in order to do machine learning on Azure, what are the different tools? As I said, and we are going to see these together during the demo, you're going to see that there are different authoring options such as automated machine learning, Designer, and notebooks. And you can just go on the Azure Machine Learning Studio, and here you're going to see that you can click on Start Now for these three different different options, and depending on which one you're going to use, of course, you're going to have a different experience. But this is really up to you. The final goal, it will remain the same. That is about building a model and an end-to-end solution that is producing predictions for you that are helpful for you and for your business. I also want to mention that I want you all to ask questions, so please use the chat. I have the chat. I just want to make sure that I have the chat here. Yes, the chat is here, is on, so feel free to ask question in this chat, and later at the end of this session I will make sure that I will reply to all the questions that you have. So these can be questions around machine learning, data science, or also question around Azure. So feel free to post them there. I want to mention that the first tool that we will see together today is Azure ML Designer. So Azure ML Designer, you can find more information here, aka.ms/Azure ML Designer is a very powerful tool because I really think it allows different teams with also different roles of people, like for example from developers to data scientists to business analysts, to talk together, work together, and see really the flow of your experiments. So it's a very nice tool also in terms of visualizations of your machine learning experiments. As you can see, and again we will see these together later, it's a drag and drop workflow type of tool. It is really great at simplifying the process of building, testing, and operating machine learning models, and is also great in terms of creating new pipeline. So you don't need to use the same experiments again to create the same pipeline, but in case you want to use the same experiments also to create a different type of machine learning pipelines, this is the tool for you. Also, you're going to see that when you are on Azure, that is our cloud platform, you can just look for machine learning and or AI. Click on machine learning and you can create this new resource. And when you are inside Azure Machine Learning, you can start building these end-to-end solution, end-to-end experiments, and you can use a different modules and different data visualization and also different model evaluation modules that can help you understand if you are building, a good model, or eventually if you need to change something at the data level, at the feature engineering level, or at the model level. It's also great because you can create your own custom model within Azure Machine Learning. So let's say that you want to use some of the inbuilt modules for data ingestions, data preparation, but then when it gets to the machine learning piece, you really want to use Python for that. So you want to build your own custom model. Well, in Designer, you can still do that. So it's not that you have to use only the inbuilt model. So this, I would say, flexibility of this tool really makes it very, very good. The other thing that is important and I would like to discuss today with you is what are the different machine learning algorithms that you can find in Designer. As you can see, machine learning is really a broad area. Thanks to machine learning, you can actually do many different things, such as predicting between different categories. You can understand images and natural language. You can discover patterns in your data. You can also predict the results based on different relationship between values. This is more like a forecasting scenario. You can find all these information also on this very important document, in my opinion, because it's a document that is very easy, very friendly to use, but the results that can give to you are very, very nice, because it's a very nice overview of what you can do, what is the potential of machine learning. So this is a great documentation to check out. And again, so all these different activities, like for example, if you want to predict between two categories, or you want to understand images and natural languages. These are all things that you can do thanks to Designer. In order to understand more Designer capabilities, we also put together this algorithm cheat sheet. As you can see, everything starts from the middle. Here is the biggest question ever that data science and machine learning are going to help you answering. This is what do you do? What do you want to do? More specifically, what you want to do with your data. And the common question is always which machine learning algorithm should I use? So the algorithm you select, of course, it depends on one aspect of your data science scenarios, as you can see here. That is what you want to do with your data, and the most important part is what is the business question, the business problem that you want to answer, to solve by learning from your historical data. As you can see here, there are many different things that you can do. Like again, depending on the question that you have, you can predict between different categories. You can predict between two categories. You can classify images and things like that, and generate recommendation. And for each activity that you want to do with machine learning, there are many different modules. These are again inbuilt modules, so you don't need to code on Azure Machine Learning Designer that you can pick. And you can start testing them and see if these are good models for the answer that you want to get with your data. Another scenario is discover structure, find unusual occurrence, predicting values, extract information from your text, and things like that. So this is again, it's an overview of all the different inbuilt modules that you can use on Designer in order to build your solution. Another important aspect, of course, is also what you want to consider in terms of the requirements. So after that you answer the first question, that is what you want to do with your data, and for this again you have the algorithm cheat sheet. There are other considerations that are important to keep in mind when you build your machine learning solution, such as accuracy, the training time, linearity, the different number of parameters, the different number of features. And for all these requirements, there is like a machine learning algorithms that actually it's the most suitable for your solution. So we explained all of these in details, both in the video series, in the data science video series, but also in this documentation, aka.ms/select-algos. You can go there and read this document and understand better how you can keep in mind additional requirements based again on your solution, and how you can make sure that Designer is the right tool for you when you need to build machine learning apps. The other authoring tool that we have on Azure Machine Learning is called Automated Machine Learning. Automated Machine Learning, I think, became very, very popular a couple of years ago because it's actually a feature that was created by Microsoft Research, and the Azure Machine Learning product team was able to integrate this feature within their product, within Azure Machine Learning. It's a great feature, it's a great tool to use because again, you can somehow you can use it in order to accelerate your machine learning development process, because this feature does what we call the best model selection and hyperparameter tuning for you. So in order to learn more, I also put this link here, aka.ms/automated machine learning, so feel free to check it out. So just to share a little bit more information around automated machine learning. It's very nice because now in Azure Machine Learning you have two different ways of consuming automated machine learning. There is the no-code UI that you can use, as you can see from this screenshot, or you can also use the code first notebook experience. So you can just you need just to call the AutoML package in Python, and you can use it using the Python SDK within Azure Machine Learning. It's as I said, it's a great option, especially if you want to increase the productivity, you want to decrease the time-consuming task of model development. So for your data science teams, I think it's going to be a great option. And the most important thing is that it's also very well integrated with the responsible AI features that are part of now of Azure Machine Learning. Yesterday, we had a great session with Stephanie and Manoush, and we talk about what are the different responsible machine learning features that you have within Azure Machine Learning, such as Interpret ML and also Fairlearn. Both these features for responsible ML are also integrated in Azure Machine Learning. So this is really great. So let's understand better what we mean with Azure machine learning, and specifically with automated machine learning. So as you can see from this slide, one problem, and this is just an example, is for example, how much is this car worth? So what's the final cost of this car? Usually what data scientists do is that they sit together as a team, and they try to answer this question: which features, which algorithm, and which parameters I should use in order to answer that question. And they start, looking at different features such as car brand, mileage, year of make, and then gradient boosters, or different type of parameters. And let's say that the first model that they get is a 30% model with accuracy of 30%. And then they keep doing these sort of experimentations. Eventually, they try to use a different features set, different algorithms. They, of course, change the parameters in order to improve their model, and they get a second model which is 50% accurate. And then they keep doing this. And finally, eventually, they get a model of 95%. Of course, this is a wonderful scenario for data scientists. So again, this is an example, but this is really what the data scientists need to do. So as you can see here, it's a very iterative process, and is also really time consuming, because again, not only you have to try different sets of features, but it's also important to try different algorithms and also do what we call the hyperparameter tuning for each algorithm. So in terms of hyperparameters, hyperparameters, as you probably know, are characteristic of the models that you are going to use in order to, and also you are going to change in order to make your model more accurate. It's very important to understand that there is no way that you know the exact values of your hyperparameters before you start working on your machine learning model. So the only way is to really manually adjust those parameters and try to understand better what are the right parameters for your model and for your data. So evaluating each configuration of your parameters is resource and time consuming. And automated machine learning is actually very interesting because it's a new feature, as I was saying at the beginning, that is trying to automate this process of machine learning model development. Automated machine learning is great because it takes uncertainty into account and incorporate what we call the probabilistic model to determine the best pipeline to try next. This approach, as you can understand, allows automated machine learning to explore the most promising, I would say, possibility without wasting your team or your time. And in terms of different AutoML capabilities. So first of all, the first thing that you need to do, and we will see this together, is that you need to identify the machine learning problem to be solved, like such as classification, forecasting, or regression. Then you need to specify the source and the format of the labeled training data, like it can be like an NumPy arrays or a pandas data frame. And then you have to configure the computer target for model training, such as your local computer or Azure Machine Learning computes, remote VMs, or also Azure Databricks is another option. And during training, the Azure Machine Learning service creates a number of in parallel pipelines that try different algorithms and parameters. So it will stop only once it hits the exit criteria defined in the experiment, and you are going to be the one who are going to define those criteria. So you have total control of what Azure Machine Learning, automated machine learning is doing for you. Then in terms of how you can write down all these configurations for Azure Machine Learning, there is this file, this class actually, that you can create, and in this class again you are going to define the different configurations that you're going to use in order to submit an auto machine learning experiment within Azure Machine Learning. This is a configuration object that contains and persists the parameters for configuring the experiment run, as well also the training data to be used at a runtime. So in order to understand better how you can create these and how you can define all the settings for this file, you can look at aka.ms/automlconfig-class. So again, this is another very important document that I suggest you to check out in order to understand better how you can leverage automated machine learning within Azure Machine Learning. The last option on Azure Machine Learning that we have and that I want to introduce to you, and after this I promise we are going to jump into Azure Machine Learning Studio, and we are going to see all these options together, is Python Jupyter Notebooks, which is probably the option that data scientists and also machine learning practitioners love the most. Before we jump into this option, let me check. Yes, okay. If everything is good, okay, perfect. So let's go back to the slide decks. Okay, so this is, I would say, this is the third option, the third authoring option that you have on Azure Machine Learning. I left this at the end because I think it's the most used and popular option for data scientists. I'm not saying for everybody, because I have to say I work with a lot of customers that actually really loves Designer, because their data science teams are composed of data analysts, and also they are very diverse type of teams, like where you can find developers, data scientists, but also business analysts, business experts. And for that typology of teams, they find that Designer is the best machine learning tool ever, because again, you can build your own customized modules, writing in Python, for example, for machine learning, but you can also use inbuilt modules. So it's really a way in order to see your machine learning data science teams work together. However, there are many other data scientists that they really like to write their own code in order to build a machine learning solution. So they use what we call the Python Jupyter Notebooks. And let's see together how you can actually use these tools. So this is very nice, because once you are in Studio, in Azure Machine Learning Studio, you just need to click on the notebooks and to connect these notebooks on a compute target that you can create again within Azure Machine Learning. And the nice thing is that these notebooks are really well integrated with the Azure Machine Learning workspace and also the different data stores. is, I would say, a great option if you want to use Azure ML, Python, and also the R SDK, because again, you can not only do all the data preparation, the feature engineering, the model training, testing by yourself, but also the deployment part. So this is great, and it's also a very advantageous, I would say, tool when you want to push your machine learning model into production, and so you want to understand better how you can operationalize your model. In order to give you also additional details, is also very well supported for Azure VM types, and also it's also great to see how there are different machine learning packages that you can use on it. So all the different open source packages in Python, all the different machine learning frameworks out there can be used in Azure Machine Learning, because again, you're basically using a Jupyter notebooks. So anything that you love, you can just keep doing that, but of course it's hosted on Azure. And is also great, as I said, in terms of deployment and operationalization experience for your machine learning models. So these are all I would say characteristics to keep in mind when you are getting started with machine learning and data science, and you want to understand better what's the best authoring option for me based on the different things that I need to do. Okay, so let's quickly go into Azure, and then from there I'm going to show you how you can use Azure Machine Learning. Just to show you a little bit more information about Azure Machine Learning, first of all, let me put my camera back, because okay, I'm here. I think you can see me now. Very nice. And also let me make myself a little bit bigger. So you can see me during this demo, and again, feel free to ask question anytime. Also, if you are not able to ask question today during this session, feel free also to contact me at my Twitter handle that I think is here. Let me put this more visible. Yeah, here we are. You can find me at FR Lazzeri on Twitter. So if you have questions also offline, because you need a little bit more time to digest all these materials or these demos, so feel free to contact me there, and we can talk more about machine learning. So just to get started with this demo, so right now, as we can see, I'm on the Microsoft portal Azure. I'm sure that many of you are already familiar with this. I'm there with my subscription, so I already did the login, and the different things that I can do here in terms of machine learning starts with create a resource. So once you click on create a resource, the only thing that you need to do is look for machine learning. As you can see, is the first option. So you just need to click there, and you can then click on create. Here, what you are going to do is you are going to create this resource that is called workspace, and you can use, of course, your subscription. You can use a resource group that you already created, or you can create also a new one here. And then in terms of workspace is really the place where you're going to start building your machine learning models. And the nice thing is that you can share this workspace with different others machine learning scientists or data scientists in order to share with them this workspace and work together. You can again pick a workspace name, the region where you are, and then also the workspace edition. Here for now you have two options. You have the basic one and the enterprise one. So again, it depends on the type of solution that you want to build. The basic one, it's great. If you want to use some of the more advanced capabilities, I would suggest you to use the Enterprise edition, just because there are just a little bit more capabilities. But if you want to just to get started, I would say that the basic option is great for you. And then you just click on review and create. And what this is going to do for you is, let me show you, because I already created one for you, is to create something like this. So you're going to see that there is the icon of Azure Machine Learning, and you're going to see a bunch of different workspaces that were just created for you. As you can see, I have many because I created many machine learning workspace. So let's just randomly, for example, pick this one. Here, this is what you're going to see once you create one Azure Machine Learning workspace. There are many different information, such as the workspace edition, your resource group, the location, the subscription ID, and also some additional information that I always check out are the different documentations. Some of these documentation I was sharing them also on my slides, but in case you want to look at, you can also look from here. And then also another important part is the GitHub repo. So this is again a very, actually let's open this so you can see that is a GitHub repo where you can find all the different notebooks or samples that you can follow in order to get started, again to get started with the Python notebooks on machine learning service. And the most important part, I would say, is how to use Azure ML and tutorials. These are the two folders that I really suggest you to start with. So let's go back to the portal, to Azure Machine Learning, to Azure portal. The other thing that you need to do is click on Launch Now. This is the Azure Machine Learning Studio. You can click on Launch Now, and actually let's click here together. And here, basically, what you're going to see is the Azure Machine Learning Studio and all the different options that I was mentioning to you before. Notebooks, automated machine learning, and designer. Also, if you want to start now, like without clicking here, you have this button here, start now, start now, start now. Again, it depends on the options that you prefer and you want to learn more about. Before jumping in one of these options, I also want to share with you a little bit more information around assets and manage. So assets, these are all the additional tools that of course you need in order to do data science and machine learning, such as data sets. These are all the data sets that you can ingest. Again, you can ingest them directly from the cloud, SQL database, from an application or from your local machines. There are also samples dataset that you can just use to experiment a little bit with these tools. Then there are experiments, pipelines, models, endpoints. So experiments are all the machine learning experiments that you are building, and we will see experiments today. And models is when you are actually going to deploy your model. So when you are ready and you know that the model that you build is the most beautiful model for your solution, you can again deploy it, meaning that you're going to operationalize creating an API that other people or other application can use in order to call this model and consume this model over time. And you're going to see a list of your deployed model here, and then endpoints that again you can use in order to operationalize and deploy your model. And then under manage you have a different compute. These are compute targets that you can create. We can see together also how you can create a compute target data source where you can store your data, both the data that you're going to use for the training part, but also the data that you're going to use for testing, and then the predictions that you're going to generate thanks to your machine learning model, and then data labeling as well. For today, I think that I want to give you a just overview of Designer. I know that there will be a wonderful session on the Microsoft Developer Twitch account on Designer by the wonderful Cassie Breview. So I'm not going to go in too many details around these, but I just want to show you how you can use this. And then let me jump into notebooks. So for designer, you just need to click on Start Now. And here, when you go under Start Now, here you see that you have a different option, and here these are just samples that you can use in order to play around. So let's click on the first one, for example. First things that you see is that under modules you have different options modules. So these are all inbuilt modules that you have in order to build your machine learning solution. So you have a data input and output, data transformation. Again, if you want to split your data into training and testing, if you want to select different columns in your data sets, if you want to do feature selection is also very, very important. Then let's say that you are done with all the data manipulation and data preprocessing part, and you want just to start with the different machine learning algorithms. Do you remember the algorithm cheat sheet that I shared with you in my slides? That is exactly the guide for this module selection. So depending on what you want to do, you can use that cheat sheet as a sort of general guideline, and then once you get a better understanding, I would say an answer from that document, you can get here. And as you can see, you have many, many different options. In terms of regression, you have the Boosted decision tree. In terms of clustering, classification, you have different algorithms, and so on. Here, for this regression, the car price prediction, they use a simple linear regression. So again, you can look at these, and you can also click on the algorithm that you're going to use, and you can look at the different solution methods, like for example, is online gradient descent versus ordinary least square, the different L2 regularization way that you want to use. Again, you can customize this a little bit based on your data and on your solution. The nice thing is that after that, as you can see, you split the data, so you use the training data set just to build your model using, in this case, you train it using a linear regression. Then you can use the testing part. Actually, let me show you what is inside split data. As you can see, you can just split your data between training and testing. In this case, we're using a split rows method, and the type of the amount of training and testing data that we are using is 0.7 for training, meaning that 70% of the data set has been used for training, and 0.3 for testing. So 30% of the data set has been used for testing the model in this specific use case. So with the split part, with the training part, you can score your model, meaning that you're using that to test your model. And finally, if you want, you can evaluate your model using this. This is like an evaluation modules that allows you to understand, based of course on the algorithm that you picked and on the solution that you're building, if your model is producing good results, good predictions or no. So as you can see, it's a very nice tool. The last thing that I want to show you here is Python language and R language. So this is very nice because, again, as I was saying in my slides, let's say that you work with a team where there are many different people who loves this designer drag and drop type of tool, but you also work in a team where there are different data scientists who wants to also build their own custom model using Python. They can do that, so they can use designer, so that you can also build a sort of hybrid solution, and a solution that use both inbuilt modules and customized modules. So here, let's say that your data scientist wants to use Python. So as you can see, you can use the execute Python script modules. The only thing that you need to do is edit code, and here you can input your Python your Python code in order to build your machine learning solution, and you can just click on save and connect this with the rest of the experiment. So as you can see, it's a very flexible. It's a very nice in my opinion. And then once you have done with this, the only thing that you need to do is submit it and then publish. The publish part is going to create for you an experiment that has a machine learning model that has been transformed into what we call the web service. So the web service, of course, is going to have a web service input and a web service output that you can use in order to use new data to consume this machine learning module. So the other option that I want to show you, I know that we don't have a lot of time, and I also want to leave a little bit of time, at least the last 10 minutes, to answer your questions, if you have any, is the notebooks. So let's go back to the main page of Azure Machine Learning Studio. And if you click on notebooks, as you can see, you can see my files or samples. The samples, I would say, probably is the best option to get started with the notebooks, with the Python notebooks in Azure Machine Learning. However, as you can see, there is also the R option. So if you are R coders, I would suggest you to go with R, if not Python. So if you're already very comfortable with the Python notebooks, you can just use the My Files part and just use and see all your folders and see all your notebooks here. So in this case, let me see what's probably the interpretability part, because yesterday I was again with Marnoush and Stephanie here, and we were talking a lot about interpretability and how you can use this interpretability toolkit within Azure Machine Learning. So let's say that you already built this. So the only thing that you need to do is click on your notebook. I think I also have it open here. And as you can see, as soon as you open this, you are going to see different options. The first thing that I really suggest you to check is the compute. Here, in case you don't have a computer that is already running for you, you can just create a new one, and this is a computer that again you're going to have on Azure. If not, if you don't want to create a new one, you can just connect these experiment this notebook with this specific compute. So in this case, as you can see, I already created this and I already connected the two. And then you can decide if you want to work here or if you want to just click here. As you can see, you have two options: edit in Jupyter or edit in Jupyter Lab. Again, it depends on you. I use both of them a lot. For this demo, we can use the Jupyter probably option because it's a very common one. And once you click on this, it's going to direct you to Jupyter Notebooks. As you can see, here is a normal Jupyter notebook. Make sure that you check the kernel. Here you have a Python 3, Python 3.6, Azure ML, and R. It depends on the case, and then you can start coding. This demo that I created for you, actually, this is another demo. Let me open a newer version that is exactly the one that we were seeing here, that is about mitigating disparities in ranking from binary data. This is a demo that also Stephanie and Manrouche were talking about yesterday. So you can see that many different things are covered in this demo. The domain, the different machine machine learning task, the different fairness task with both machine learning interpretability toolkit and fairness, the different performance metrics and the different mitigation algorithms that you can use. The most important part that I want to show you today is actually after the data set. As you can see here, you are coding in normal Python, so you're not really doing anything different. So after that, you test the data, make sure that you have load the data using the temp package and everything is working, meaning that your data is accessible. You can combine all the training data into a single data frame and look just a little bit at a few rows, as you can do here. And then you can also look at the data, I would say, more closely. Here we look at the distribution of LSAT and UGPA by race. And this is, again, it's a nice overview of how you can look at the different metrics with these two categories. And then you can start using what we call the scikit-learn model, and we are going to use specifically the logistic regression. So here the main goal is to use first a standard logistic regression predictor that does not seek to incorporate any notion of fairness, just because later in the notebook, as you will see, you're going to compare actually the different results based also on different algorithms. The other thing that I want to share this with you is how you can use the mitigating demographic disparity with the grid search. So grid search is these mitigation algorithms that you can use as part of FairLearn, and it is again integrated in Azure Machine Learning. And here the most important part, the most important point that you can look at is that is generating different type of models that corresponds to different type of Lagrange multiplier vectors, and you can understand also what is the underlying constraint optimization problem. So this is very nice to look at here. As you can see, you are just importing this calibrated classifier CV. And the other thing that you can look is look at the accuracy and disparity of the obtained predictors in this scatter plot. Here, as you can see, the x-axis is showing the worst case AUC among the two subpopulation. So these are again students, different categories of students, and the y-axis is actually showing the demographic disparity. I would say that when you use a FairLearn, the best results that you are hoping to get, so the best ideal models would be in the bottom right. Again, this is just an overview. I will let you all play a little bit around with these notebooks that are in the machine learning repo. Is again aka .ms/Azure ML repo. You can find all these tutorials and all the notebooks that we put together for you. Before we jump again into the slides, the last things that I want to show you in terms of notebooks is the fact that every time that you create a machine learning experiment and you decide to run it, Azure Machine Learning creates a pipeline runs for you. As you can see, all these runs are stored here. Here there is, for example, run 1 and run 12 with a different run ID, the experiments, the status, the description, when was it created, the different duration, and so on. So this is another way of looking at the different pipeline runs that are important when you are building and running multiple machine learning models, but also the pipeline endpoints and the pipeline draft. So you really have an overview of what is going on in your machine learning workspace, which is great. Okay, so let me go back into the slides. The last things that I want to share with you is again all the resources that we have been using today and also in the video series. So if you want to learn a little bit more about machine learning, data science on Azure, I would really suggest you going to these two resources. The first one is a video series. It's a 28 videos around machine learning, data science on Azure. They are very short videos, so you can also just pick the ones that are most interesting for you. And also there is the GitHub repo if you want to not only watch the videos but also do some exercises by yourself. In the video series, we explain also what is a data science lifecycle. So let's say that you have a big team of data scientists and developers, and you want to follow some guidelines in order to build your solutions. This is something that can be very helpful for you. The algorithm cheat sheet that we saw together today, also automated machine learning and Azure Machine Learning. So these three things, we saw all of them together today. Then the Azure AutoML featureization. This is part of automated machine learning. So how you can build a different set of features for your machine learning model in order to make your machine learning algorithm more accurate. And finally, also how to select machine learning algorithms and model interpretability. So how to select machine learning algorithms is very important to keep in mind. Is again here you can find select algos document where we list all the different requirements that you should keep in mind every time that you build a machine learning solution. And the model interpretability is a very important topic right now, together with assessing fairness in AI solutions. So I will leave you here. Before I say goodbye, I just want to check the chat and see if there are any questions that I can quickly answer here. If not, I will just reply to them on the chat. So I will also stay a little bit after this. This is great. So I have a question. Can you explain how do you get results out of Azure? How does this API web service work? Yes, this is a great question. So let me see here. Actually, let me go back to Studio. So every time, let me see if here I have some endpoints. Here probably I'm not in the right workspace. So let me change a workspace. Just to give you an overview, by the way, yes, you can get that results using the endpoints part. And so here you can also in the models part, you can get all the different information that you need. So in this specific workspace that I'm using for this demo, and I randomly pick it, there is Azure ML underscore Francesca is the name of my workspace. Every time that I deploy a model, I'm going to see models, and here basically if you click on the name of your model, you're going to see not only the different details but also the artifacts. So this is the model pickle file. If you're familiar with the pickle file, it's really a folder that contains all the information about your model, such as the input and also the run functions. These are all information related to your model, but also additional information such as what are the different Python packages that you need to install and to use in order to run your model, and many different other information. So this is one place, and then you can look at the endpoints, and it's nice because you have also explanations that you can get. So the endpoints, as you can see, you have the REST endpoints that you can use to call this web service, and also what we call the URI. Here again, this is another URI that you can use in order to call and consume your machine learning model. So these happen only after, of course, you run your experiment, so you train it, you test it, and then you decide to deploy it as a model. And here again, you can find all the different informations. So again, I hope these answer your question. We have another minute, so I would love to answer the last question, and then I will, I will stay here and answer your question offline, so don't worry. The other one that I see is the setup with R seems the same. The API seems confusing with R. Yes, the with R, I have to say that probably I'm not the best person to answer questions on how you can use R within Azure Machine Learning. However, I can tell you that R is something that has been added later. The Azure Machine Learning product team started with Python, so everything is now very well now working very well with the Python, and with R they're still working on it. So if you think that there are a few things with R that are not really clear and they are still a little bit confusing, please feel free to reach out to me. I will be happy to communicate this feedback to the product team, or actually put you in contact with the product team who is developing the R part for Azure Machine Learning. And then the last question is, how do these notebooks compare to Azure Databricks notebooks? Another wonderful question, this one. So with the Azure Databricks notebooks, of course, you're going to find packages that are, and not only packages, functions that are related to Spark on machine learning on Spark. So the type of packages and functions that you're going to use there are just a little bit different, but I would say in terms of functionalities are exactly the same. So I did a talk at Spark AI Summit a month ago, I think, and I was using Azure Databricks, Azure Machine Learning, and also the different Interpret ML and Fairlearn packages. So I would say in terms of functionalities and capabilities is exactly the same. Of course, since you are on Databricks, there are a few different things in terms of packages and functions, the names and that you can need to update or change in that sense. But I don't see again any difference in terms of functionalities between the two. So if you are working for a company who is already using a Spark and they are already using Databricks, I would suggest really to look at the documentation, and I can put some of the documentation here for you. So unfortunately, we are running out of time. So I want to just say thank you so much to all of you who joined this session. I will stay here, so I will keep answering these questions offline. And yeah, have a good night. You too. Thank you so much.